All right, so now I'm about to go over how to do systems and pulleys problems. Now, before I actually dive into the problems, I want you to know that a system is when we have two masses that are connected to each other. Two or more masses. So it could be three things connected, four things connected, but you have multiple things connected to each other. And however much this one accelerates down, this one accelerates this way. So you should know that both of these objects have the same acceleration. Likewise down here, however much this accelerates this way, this is going to accelerate that way. So we have the same acceleration of all objects. One thing you should also know is that the tension here is equal to the tension here because it's the same string. The tension here is equal to the tension here because it's the same string. And the steps to solve Pulleys problems are to make a free body diagram for object 1, then a free body diagram for object 2 in the direction of motion. So since this is moving in the x direction, you do your free body diagram for the x direction. Since this one's moving in the y direction, you do the free body diagram in the y direction. And likewise, since both of these are moving in the y directions, you just do the free body diagrams for the y directions. So once you have your free body diagram here and your free body diagram here, note that this is going to have tension in the x direction that it's moving. This is going to have tension in the y direction that it's moving. So both equations will have tension in there. So solve the free body diagram here for tension and the free body diagram here for tension. And just like in math, if t is equal to a and t is equal to b, then you can say that a is equal to b. So when we have our equation for tension here and we have our equation for tension here, we can equate those two equations to solve for the acceleration. Because for these problems, we're going to be, one, looking for acceleration, and then we're going to be looking for tension. So in this first video, I'm going to be talking about the Fletcher's trolley, and then without friction. And then I'm going to talk about Fletcher's trolley with friction, and then I'm going to be talking about Atwood's machine. Because these are the two types of systems that we're going to be working with. Give me 1 second to get my calculator. All right. So for this first question, it says a 15-kilogram box rests on a frictionless horizontal surface attached to a 5-kilogram box hanging off of the side of the wall. What is the acceleration? What is the tension in the rope? So like I said, first thing you want to do is draw your free body diagram for the motion of the first box. So this will be box 1, this will be box 2. So the motion for this box is in the x direction. So looking at the free body diagram for the x direction, you have tension this way. And note, we don't have friction because it says it's a frictionless surface. So the sum of the forces in the x direction is tension. And we're looking for the acceleration when this starts to move. So the sum of the forces should be equal to ma. But a key difference in these types of problems are that we have two masses. So for this one, I'm talking about the first box, so I want to put mass 1. And since it's accelerating in the x direction, I want to say it's 8x. So t is equal to m1ax. Likewise, for object 2 is moving in the y direction. So I have my free body diagram, I have gravity pulling it down, but it's the gravity of the second object. And we have tension pulling it up. So the sum of the forces in the y direction are tension minus the force of gravity for the second box is equal to ma. But we're talking about the second box, which is m2, and it's accelerating in the y direction, which is ay. Now, pay very close attention because this box is moving down. And since it's moving down in the negative y direction, we have to account for that by putting a negative. So tension minus the force of gravity is equal to negative ma. Then I'm going to solve this equation for tension. So tension will be equal to negative m2 ay plus Fg2. Now I have T equals this and T equals this. So I can set these two equal to each other. Because remember, if T equals A and T equals B, A equals B. So I get M1AX is equal to negative M2 AY plus Fg2. Now remember, we're looking for acceleration. So, and we said that the acceleration is going to be the same. However much this is accelerating down is how much this is accelerating across. So, I can rewrite this as M1A is equal to negative M2A plus Fg2 because they're going to be the same. Now to solve for A, I need to get all terms with A on one side of the equation. And I do that by moving this one over here. Next step is to factor out the A. So if I take A out of both of those, I'm left with M1 plus M2 is equal to Fg2. So A is equal to Fg2 over M1 plus M2. So remember, this is the force of gravity for the second box, and Fg equals mg. So the force of gravity for box 2 is m2, which is 5, times the acceleration of gravity, which is 9.8, divided by both the masses added, 15 plus 5, which is 49 divided by 20, which gives you 2.45 meters per second squared. So acceleration is 2.45 meters per second squared. Now for this last part, we have to calculate the tension. And what's nice about that is that we have two equations for tension. We have T equals M1AX, but we also have this equation for tension. And at the beginning of the video, I told you that the tensions are going to be the same. So whatever this tension is, it's going to be the same for this tension. What that means is I can use any one of these equations to calculate tension. And I'll get the same answer. So using the first equation, T equals M1AX. Mass 1 is 15 times acceleration, and we just found that. That was 2.45 equals 15 times 2.45 gives you 36.75 newtons. And using this equation, the second equation, and I'm just going to show it to you guys so you can see that you get the same exact answer. You get negative, that was 5 kilograms times 2.45 plus 49, which was the force of gravity for the second object. So negative 5 times 2.45 is equal to negative 12.25 plus 49, which gives me 36.75 newtons. So I get the same exact answer no matter which equation I use, which I should, because like I said, the tension here is equal to the tension here. In the next video, I'm gonna talk about when we have this type of system when there is friction.